In this video, I'm going to briefly explain DMARC, DKIM, and SPF. So these are three email authentication standards or mechanisms that help protect your email from unauthorized email use, like spoofing or phishing. DMARC was developed around 2011 after we already had DKIM and SPF, and it really helps specify how to handle messages that are not authenticated because they've either failed DKIM or SPF checks. All these records are simple text records that just live in your zone file. And if you're unfamiliar with zone files, they hold all your DNS records. And DNS record is just an entry in that file, in the zone file, that translates requests. Usually it's to map a name, a domain name, to an IP address. But in this case, it's just text, plain text, describing what sort of checks should be done by the receiving email server. So a typical SPF record might look something like this, and that text line just tells receiving mail servers which host names or which IPs are allowed to send email on behalf of your domain. So if an email comes from a server that's not listed, it will fail the SPF check. DKIM is a bit more complicated. It uses cryptographic signatures and hashing and defined rules to prove an email hasn't been tampered and that it's really come from your domain. So say your mail server is Microsoft Office, for example. Your mail server will first create a hash from your outgoing email. This hash will be combined with your private key in a specific operation to produce a signature. And this means that your email is mathematically proven to come from you because you're the only person with that private key. It will then add this to the email as a header called a DKIM signature, which also says how and what was hashed so the recipient can copy the operation later. When the receiving mail server, so my mail server, reads the header, it can copy the process you've done to get the same hash value. It then looks up your public key in your DNS record and uses this for the verification process. So by applying the public key to the signature, it will produce the same hash value the sender originally computed. And then if that value matches the value that you've computed, then the signature is proven valid. So the email or part of the email isn't encrypted for privacy. It's actually creating a digital signature because the goal is not for confidentiality here, but it's for authenticity and integrity. So just to reiterate, DMARC is built on top of SPF and DKIM, and it tells receivers how to handle emails that fail either of these checks. So a DMARC record might look something like this. P equals reject is the important part here. You've probably heard that before if you've come across DMARC. And that means if an email fails either the SPF or DKIM checks, the receiving server should reject it outright. So if you've published P equals reject in your zone file, I know that if an email has failed either of these checks, you don't want me to look at it. So I'm not going to look at it. The other option includes P equals quarantine or P equals none. But these tell the receiving server to report back to you on any emails that might have failed the checks, but it doesn't tell me to disregard the email. So I'm going to still assume the email comes from you, even if it's failed SPF or DKIM checks. So when fully enabled and configured correctly, you can pretty much guarantee no scammers or phishers will be able to send emails that appear to come from your domain. It's not a foolproof way to protect your staff. For example, someone could still register a similar domain to yours. But if your CEO is supposedly sending an email to HR asking for money to be sent to a random account, and DMARC is set up correctly, then you can be sure that that email, that fake email will never arrive. If you have any questions or need help setting up DMARC, feel free to reach out. Thanks for watching.